Hello friends, today we are going to solve a numerical from the lesson solutions. Let's begin. At 25 degrees Celsius, 0.1 molal solution of acetic acid is 1.35% dissociated in an aqueous solution. From this sentence, we understand that the temperature given is 25 degrees Celsius. That can be converted into Kelvin by adding 273.15 so that we get 298.15 Kelvin. Molality of the solution is given 0.1 molal. The next thing is percent alpha, that is percent dissociation, is 1.35%. From this, what we can find out is alpha. We have the formula percent alpha equals to alpha into 100. Therefore, alpha would be equal to percent alpha divided by 100, that is 1.35 upon 100. So I can write this as 1.35 into 10 to the power minus 2. Alpha doesn't have any units, so we'll keep it as it is. The next part of the question says calculate freezing point. Calculate freezing point means we have to find out TF and osmotic pressure pi of the solution. So freezing point of the solution and osmotic pressure of the solution. And we have to assume molality and molarity to be identical. Now the solution is of aqueous solution is there of acetic acid. So acetic acid is the solute, and acetic acid when dissolved in water dissociates as acetate ions and H plus ions. That means the number of particles involved over here is 1 plus 1, that is 2 particles. So we have to consider 2 particles over here. One is acetate and one is H plus ions. So N dash is equal to 2. So from alpha, we can actually find out I. We have the formula alpha equals to I minus 1 upon N dash minus 1. Alpha is 0.0135, which we have got from here. I just shifted the decimal. So 0.0135 equals to I minus 1 upon N dash, that is 2 minus 1. So 2 minus 1 is 1, and here we have 0.0135. So I will be equal to 0.0135 plus 1, that is equal to 1.0135. That can be rounded off to 4 digits, 1.014. This is our I, that is Van 't Hoff factor. After finding out Van 't Hoff factor, let us find out delta TF theoretical. Now, delta TF theoretical is equal to Kf into M. Now, we will be having two values here. One is delta TF theoretical and the other one is delta TF observed. So, first of all, let us find out delta TF theoretical. Observed value is the one which we'll find out from Van 't Hoff factor I. So let's first find out delta TF theoretical, that is equal to Kf into M. Kf is cryoscopic constant for water, that is 1.86, and molality is given in the question as 0.1. So we get the value 0.186, and this can be written as Kelvin or also in degrees Celsius because it is a difference. Next formula we use is I, that is Van 't Hoff factor, is equal to delta TF observed upon delta TF theoretical. Now we already know the value of I, Van 't Hoff factor. We have also found out delta TF theoretical. So from these two we can find out delta TF observed, which will be written as Van 't Hoff factor multiplied by delta TF theoretical. Van 't Hoff factor we have got as 1.014 and delta TF theoretical we have got it as 0.186. So the log of 10 under 1 mean difference 4 is 0060 and 18 under 6 is 2695. I've also taken the characteristics for both of them. Now let's add the two log numbers since there is multiplication sign. So let's add them. 5, 9 plus 6, 15, 5, 1, 7. This is 2 over here. 0 plus bar 1 will be bar 1. Now we have to find out the anti-log of 0.27 under 5 mean difference 5, which comes out to be 1886. Directly put a decimal after one digit into 10 to the power minus 1. So you can shift the decimal and we get 0.1886 degrees Celsius, or you can also write it as Kelvin. Now the next thing what we find out is TF, that is freezing point of the solution. That can be found out as delta TF equals to TF naught minus TF. So this delta TF is nothing but delta TF observed. Now let's take TF on the other side so that it becomes positive sign, and here we'll be having TF naught minus delta TF observed. TF naught is the freezing point of the solvent and the solvent is water. And for water the freezing point is 0 degrees Celsius. So 0 minus 0.1886, that comes out to be minus 0.1886 degree Celsius. Therefore, we have found out the freezing point of the solution. Now we still have to find out pi observed for the aqueous solution of acetic acid. So pi will be equal to, pi is equal to MRT. But we have to multiply it by Van 't Hoff factor I, since acetic acid is dissociating in the solution. Now in the question they have mentioned that consider molality and molarity as equal to each other. So since molarity is equal to molality, therefore what we will do is we will replace capital M molarity by small m molality. I Van 't Hoff factor is 1.014. Molality given in the question is 0.1. R, that is universal gas constant, we have to take 0.08205 multiplied by the temperature which is given at the beginning 25 degrees Celsius, which is converted to 298.15. Now let's take the log of the numbers here, and finally we will be finding out the anti-log of the number what we are getting. So this we can write at the end also. So the log of 10 under 1 mean difference 4 we have already found out, 0.0060. Let's keep 0.1 outside, that will be written as 10 to the power minus 1. Then bar 2 0.82 under 0 mean difference 5 is 9141. 29 under 8 mean difference 2 is 4745. Since there is multiplication sign amongst them, so let's add all these numbers. 5 plus 1, 6. This is 10 plus 4, 14. 1. This is 8, 9. 9, 4, 13. 3, 1. 2 bar 2 is 0 and we have 1 carried, so 1 point. Let's take the anti-log of 0.39 under 4 mean difference 6. So we get it as 2480. Directly putting a decimal after one digit into 10 to the power. This number before the decimal is the power, that is 10 raised to 1 into 10 raised to minus 1. This gets cancelled off and we get the final value as 2.48 atmospheres. That is pi. I hope you have understood the numerical properly. Thank you for watching my video.